All right, we're going to be working on section 5.4 of your intermediate algebra book. That starts on page 192. For example 1, we'll start with letter A. It says multiply the radical expressions, the square root of 2 times the square root of 8. When we multiply radicals, there's one thing you have to remember, and that's just multiply the numbers that are inside, multiply the coefficients on the outside. Well, usually we do the coefficients first, then we do the inside numbers first. Since the coefficients are both 1, we don't need to worry about that. When we multiply the radicands, 2 times 8, we get 16. And then, of course, we're going to simplify. The square root of 16 is 4. All right, for letter B, again, we're multiplying the square root of 3 times the square root of 6. The coefficients are still 1, so we're going to multiply under the radical. The radicands, when you multiply them, make the square root of 18. 6 times 3 is 18. Now we do need to simplify anytime we have something under here with a perfect square in it. And we know that 18 is 9 times 2. So to simplify it, the perfect square 9 comes outside as a 3. And we end up with 3 on the outside from that 9 times the square root of 2 still left on the inside. Letter C, our cubed roots. The cubed root of 2 times the cubed root of 16 times the cubed root of 4. The rule is you can't multiply these unless they do have the same index. So even though there are 3, the rules are still the same. We're going to multiply these radicands underneath. And we're going to get a cubed root of 2 times 16 times 4 is 128. And of course you can use your calculator for that if you want to. Then we need to simplify that. 128 is actually 64 times 2. And 64 is a perfect cube. We know that it's 4 times 4 times 4. Because since this is cubed root, we're looking for perfect cubes. The other way you could do this is to take the 128, use a tree on it, and break it all down to prime factors, and then look for a group of 3 the same. You'd have 3 4s here. So that turns out to be the cubed root, there's a 4 on the outside, times the cubed root of 2. The cubed root of 64 is 4, so that comes to the outside. This one doesn't have any partners, so it stays on the inside. Letter D says 2 times the square root of x times 3 times the square root of 2x. And now this is the first time we see that there are coefficients on the outside. You multiply the coefficients first. So 2 times 3 is 6. And then you multiply underneath the radical square root of x times the square root of 2x. You just multiply x times the 2x, and that's going to stay under the radical. So that would be 2x squared. Then we see if there's anything under here we can simplify. Well, we can, because this x squared is a perfect square. This 2 doesn't simplify, but this x squared, we can take the square root of x squared is x, and so that x is going to come to the outside. So we'll still have our 6. We'll have a new x on the outside. Left inside is the 2. So this 6 stays here. The square root of x squared is x, so that's where this x is coming from. This 2 you can't simplify, so that stays under. Letter E says 1/2 times the square root of 3 times 3/4 times the square root of 8. And this looks a little complicated with the fractions. So you really have to know your fraction rules. These are the coefficients, so we're going to multiply 1/2 times 3/4, and I think I'll take it over here to do it. 1/2 times 3/4. When you multiply fractions just straight across, top times top, bottom times bottom, that comes out to be 3/8. So our coefficient is going to be 3/8. Then we multiply underneath the radical 3 times 8, and that's going to give us 24. Now we need to simplify. There is a perfect square under here. That perfect square is 4. So we still have 3/8 in the front. The 24 we're going to break into 4 times 6. The square root of 4 is 2. So the 2 is going to come to the outside. What is going to happen? This 3/8 is going to actually get multiplied times that 2. So we're going to have 3/8 still on the outside times the 2 and the 6 on the inside. So we're going to take that over here and we're going to multiply 3/8 times 2. You can cross cancel these and you end up with 3/4. So that's what turns out on the outside, and the square root of 6 is still left on the inside. For example 2, we're still multiplying. This is still page 192. We're going to do example 2. We're going to start with letter A, which says the square root of 7 times 2 plus the square root of 3. So what you have to remember is this is 2 terms here, so this is going to end up being distributive property. When you multiply a radical times a whole number, you have to remember not to mix them. This is a coefficient is always going to stay on the outside. This is a radicand is always going to stay on the inside. You do not multiply a radicand times a coefficient. This is not going to turn into a 14. The outside numbers stay outside, the inside numbers stay inside. What this is going to turn into is, when you multiply this times this, is going to be 2 times the square root of 7. And then when you multiply this times this, they are both radicands, so you can multiply them since they're both underneath, and that's going to turn into the square root of 21. So outside numbers stay outside, inside numbers stay inside. If you multiply 2 inside numbers, they multiply and they stay inside. So let's do letter B. We've got the square root of 2 times 3 square root of 8 minus square root of 10. And of course we have the same things going on where we're going to do distributive property. When we multiply this term times this term, you have numbers on the outside. So you have a 1 here, the invisible 1, times the 3. That's going to give you a 3 on the outside. And then you have the radicals, the 2 times the 8, giving you 16 on the inside. We'll simplify that in a second here. And then we're going to multiply here. The coefficients are both 1, so you don't need to worry about that 1. We're going to have a negative sign. We're going to multiply the 2 radicands. 2 times 10 is 20. Now we need to simplify. So we know the square root of 16 is 4. That 4 gets multiplied times the 3 and makes this term 12. Over here on the second term, there's a perfect inside there of 4. 20 is 4 times 5. The square root of 4 is 2, so the 2 is going to come to the outside. The square root of 5 is going to be left in. For letter C, we have the square root of 5 times the square root of 10 plus the square root of 8. Again, distributive property. When you multiply here times here, the coefficients are both 1, so we can multiply under the radical. 5 times 10 is 50. And then when you go here times here, again, both under the radical. 5 times 8 is 40. Then we simplify. 50 is 25 times 2. So that 25 we square root, bring to the outside. The square root of 25 is 5. This becomes 5 square root of 2. The 40 has a 4 times a 10 inside it. So the square root of 4 comes to the outside as a 2, and the 10 stays underneath. And that's your final answer there. All right, we're working on example 3. It's on the next page, page 193. Letter A says the square root of 3 plus the square root of 5. Can I erase that? No. Okay, the square root of 3 plus the square root of 5 times the square root of 6 plus the square root of 3. Now when you look at this, this is a binomial, 2 terms times another binomial. You're going to have to use double distributive, or what students commonly call FOIL, to multiply these. You're going to multiply here times here, then here times here, then here times here, and here times here. You're going to have 4 multiplications. When you do that, each time you multiply 2 terms together, you have to multiply the coefficients and then the radicands. Now this is not going to be too difficult with this example because all the coefficients are 1, so we really don't need to even think about what's happening with coefficients. So first we're going to go here to here, and we're going to have the square root of 18. Then we're going to go here to here, and we'll have the square root of 9. Now those can both be simplified, but we're going to do that as the second step. We'll do the multiply first. Then here to here gives us the square root of 30. And here to here gives us the square root of 15. And I'm seeing that I made a mistake. Did you guys see it? 3 times 3 is not 18, it's 9. So let's fix that. Okay, so I made a mistake when I tried to fix my mistake. I had it right the first time. When we multiply here to here, we do get 18. I don't know why I thought I made a mistake the first time. Now we need to simplify. So 18 is 9 times 2. So this 9 is a perfect square, and it will bring a 3 to the outside. So we're going to have 3 square root of 2. This square root of 9 is a perfect square, so we'll just have a 3 there. Over here, 30 doesn't simplify. There are no perfect squares in 30, and there are no perfect squares in 15. So those are not going to simplify, so this is going to be your final answer. For letter B, we have 1 plus the square root of 7 times the square root of 5 minus 4. And we're going to multiply here times here. Don't forget, this 1 is on the outside. It needs to stay on the outside. This square root of 5 is on the inside. So that's going to turn into 1 times the square root of 5. You don't really need the 1, but I'm going to write it just so that you guys can see it. Then 1 times negative 4 is, of course, negative 4. And then square root of 7 times the square root of 5. 7 times 5 is 35, and they're both underneath, so they multiply underneath. Then when you multiply this square root of 7 times this negative 4, this one's on the outside, this one's on the inside. They do not mix. This one will stay on the outside as a negative 4, and the square root of 7 will stay on the inside. None of these will simplify, and they're not like radicals at all, so that's going to be your final answer. For letter C, I have the square root of 2 plus 3 times the square root of 2 minus 3. And working through my double distribute again. Square root of 2 times square root of 2 is square root of 4. We'll simplify in a minute. Square root of 2 times negative 3. The negative 3 is on the outside. The 2 is on the inside. And then I go here to here, and I have a positive, again, 3 on the outside, square root of 2 on the inside, and then 3 times negative 3, negative 9. And it looks like I can simplify some of these. For instance, these are like radicals, and if you remember this from a previous lesson, you can add these because they're both square root of 2. But when you look at the coefficients, you've got a negative 3 and a positive 3, so they actually cancel each other. And what we end up with is a 2, square root of 4 equals 2, minus 9, which is negative 11. And no, it's not. Two minus 9 is negative 7. Your final answer. Okay, letter D. We're still working on example 3, page 193. The square root of 6 plus 7 times the square root of 6 plus 1. All right, square root of 6 times the square root of 6 makes a square root of 36. Square root of 6 times 1 is a square root of 6. 7 times the square root of 6, 7 on the outside, square root of 6 on the inside. They don't mix together. Keep the coefficients outside, the radicals inside, and 7 times 1. And we can add some of these together here. First of all, the square root of 36 is 6, so we can simplify that. These are both the square root of 6, so we can add them together. This is a 1 plus a 7 makes 8. So this will be 8 square root of 6, and then I have the plus 7 from the end coming down here. One more step because I still see some more like terms. 6 and 7 are like terms, and that makes 13. Plus 8 square root of 6. Now one thing you have to remember is this 13 and this 8 cannot add together because this one has a square root of 6 on it and this one doesn't. So this is your final answer here. I have seen a lot of students then add the 13 and the 8 and make this into 21 square root of 6, but that is incorrect because these are not like terms. So this is your final answer here. All right, let's go to letter E. The square root of x plus 7 times the square root of x plus 1. All right, square root of x times the square root of x makes a square root of x squared. Square root of x times 1 is a square root of x. 7 times the square root of x is 7 square root of x. 7 times 1 is 7. Do we have anything that will simplify? Of course we do. The square root of x squared is x. So we're just going to call that x. These are like radicals because they both have the square root of x, and don't forget this one has a 1, so 1 plus 7 is 8. So this is 8 square root of x, and then down here at the end we have a plus 7. Are any of these like terms? It doesn't look like any of these are like terms, so we're done here. This will be your final answer. We're going to go to letter F. Which says square root of 2y plus 7 times square root of 2y minus 1. All right. So still double distribute. The square root of 2y times the square root of 2y is the square root of 4y squared. 2y times 2y. Square root of 2y times negative 1 is negative square root of 2y. 7 times the square root of 2y is 7 square root of 2y. And then 7 times negative 1 is negative 7. And then, of course, we're going to combine like terms. Simplify. This is a perfect square, so we're going to square root this. and make it 2y. These are like radicals because they both have square root of 2y. And remember, this is a -1, this is a +7. When I add them together, I'm going to get +6 square root of 2y. And at the back, I have the -7 still there from here. You can't add these. They aren't like terms because this one's a square root and this one's not. And so this is done now. This would be your final answer here. All right, we've got one more in this example. We've got letter G, which is really looking complicated. The square root of x minus 2, and those are both under the radical, plus 3 times the square root of x minus 2 minus 3. Okay, so I think we're going to have to take this one kind of slow. I don't know. When you multiply here times here, the x plus 2 is all under the radical, x minus 2, and this x minus 2. So we need to multiply x minus 2 times x minus 2, and it's all going to be under the radical. The simple way to do that is just to keep the radical and say we're going to multiply x minus 2 times x minus 2, or x minus 2 squared. Because then it will simplify really easily to just make x minus 2, because if you remember, this square and this radical, since it has the same index, they cancel each other. So this just turns into an x minus 2. Then we're going to multiply this times this. Well, this -3 is a coefficient, so it stays on the outside. This is a radical. So we're going to end up with -3 times the square root of x minus 2. I'm going to put parentheses around that. So we can just carry, well, let's see what's going on next. Then we're going to have this +3 times the square root of x minus 2. And then we're going to have +3 times -3, which makes -9. Okay, so the good news is these two terms here in the middle are going to cancel each other because this one's got a +3 coefficient, this one's got a -3 coefficient, but the radicands are the same. So we can cancel those two right out. So that means we just need to carry this -9 down here, like that. So when we combine these like terms here, we end up with x minus 2 minus 9, which equals x minus 11. And that's your final answer there. All right, we're still on the bottom of page 193. We've got a couple definitions down here. The first one being the quotient rule for dividing. If you're dividing, or if you have some kind of fraction under a radical, it's the same as if you separated the numerator and the denominator individually, provided the denominator does not equal 0. And then we have the definition of what a conjugate is. I spelled that wrong. There we go. A conjugate is a binomial that has the same terms as another binomial with the opposite sign in the middle. We use conjugates to clear radicals out of the denominator of fractions. So you can see on the bottom of page 193 some examples of conjugates. But we're going to go to the next page, page 194, and we're going to start with example A. Example 4, letter A. It says the square root of 9 over 49. And again, using the rule for division, you can separate this numerator and this denominator and simplify them individually. The square root of 9 is 3, the square root of 49 is 7, so this turns into 3 over 7. In letter B, we have the square root of 18 over 3. You can simplify that 18, which is 9 times 2. That 9 comes to the outside as 3. This becomes 3 times the square root of 2. The denominator still has 3, so those 3's can cancel, and you just end up with the square root of 2. For letter C, we have the square root of 54 over the square root of 6. Now, the rule for division says that you can separate a fraction into numerator and denominator like we did in letter A, but also says that a fraction that's already separated you can put back together. The only time it's really useful is, okay, I can't scroll that for some reason. If the 54 is really divisible by 6, which it is in this case, so we can put these back together because 54 divided by 6 makes 9, and the square root of 9 is 3. This is a faster way sometimes to do things. So, for letter D, we have the cubed root of 27 over 64, which we can separate out. The cubed root of 27 over the cubed root of 64. 27 and 64 are perfect cubes. If you know those, what number, when you use it 3 times, will multiply to make 27, and that is 3. And same thing with 64. What number will multiply together 3 times to make 64 is 4. And this turns into 3 over 4. Letter E is the square root of 48x cubed over the square root of 3. And this is similar to example C. I'm going to figure it almost the same. 48 is divisible by 3. So it is beneficial to put this back together and make one fraction out of it. 48x cubed over 3. And then you can simplify that fraction to make 16x cubed. 48 divided by 3 is 16. And then I'm going to simplify that radical there. 16 is a perfect square, so I know that I can get a 4 on the outside from that 16. X cubed is not a perfect square, but when you separate it up, you can make x squared times x, so that when you simplify x squared, you're going to get an x on the outside. So we're going to have a 4 from the 16, we're going to have an x, and this x is going to have to stay in. So we're going to have 4x on the outside with an x on the inside there. All right, letter F says the square root of 25 over the square root of 7. And we could put these back together if we wanted to and make one fraction, but it's not really going to help us because 25 is not divisible by 7. So it doesn't really help to put it back together. Instead, we're just going to simplify this 25 to make it 5, and the square root of 7 is going to stay in. Now we come to a rule that I don't think we've talked about before, and that is that you cannot leave a radical in the denominator of a fraction. So we call this rationalizing the denominator. To get rid of a radical here, you just multiply it. If it's a monomial, multiply it times itself. So we're going to multiply this times the square root of 7. And of course, if you know about this multiplication, the square root of 7 times the square root of 7 makes the square root of 49. I'm going to write that here. This makes the square root of 49, which simplifies to make 7. Across the top, we're going to multiply don't forget, whatever you do to the bottom, you also have to do to the top. So we're going to end up with 5. These have to be the same. 5 times the square root of 7 makes 5 square root of 7. And I'm sorry, those got squished together a little bit. All right, we're going to work on letter G next, which is 3 over 4 plus the square root of 5. All right, so this is the concept here of rationalizing the denominator. You have to get this radical out of the denominator. There's no other way to simplify this. So this is not a monomial. We talked about above, if it was a monomial, multiplying it times itself. But if it's a binomial, you multiply times the conjugate. So the conjugate of 4 plus the square root of 5 is going to be the same terms with the opposite sign in the middle. So 4 minus the square root of 5. And whatever you do to the bottom, you also have to do to the top. So this is going to turn into double distribute or FOIL. And you're going to have to do 4 multiplications here. So 4 times 4 is 16. 4 times the negative square root of 5 is negative 4 square root of 5. Then 4 times the positive square root of 5 is positive 4 square root of 5. And then square root of 5 times negative square root of 5 is negative square root of 25. And you can simplify all of this. These two middle terms cancel, and that should always happen when you multiply conjugates. The two middle terms should always be opposites, and they will cancel. So what you end up here with 16 minus, and the square root of 25 is 5. So 16 minus 5, which is 11. And that's going to be the denominator, 11. The numerator, on the other hand, doesn't cancel. You have this 3 times this binomial, so this is going to be distribute. You're going to distribute this 3. So if it's helpful, you might want to put parentheses around this binomial. 3 times 4 is 12. Then 3 times the negative square root of 5 is negative 3 square root of 5. And you're done. We're going to do letter H. We've got x over the square root of 3 minus 1. And this is the same concept again. We're going to use the conjugate of the denominator. So we're going to use the square root of 3 plus 1. And we're going to distribute or FOIL this. So first, square root of 3 times the square root of 3 makes the square root of 9. The square root of 3 times 1 is the square root of 3. Then negative 1 times the square root of 3 is negative square root of 3. Then negative 1 times positive 1 is negative 1. And then we simplify. Square root of 9 is 3. These two middle terms cancel each other. So we have 3 minus 1, which is 2. So this denominator turns into 2. In the numerator, you're going to distribute this x. So when you do that, you have x times the square root of 3. The x is on the outside. The square root of 3 staying underneath. And then you have x times 1, which is, of course, just x. And that's finished. All right, for letter I, we have 4 over the square root of 5 minus the square root of 2. We're going to multiply times the conjugate of the denominator, square root of 5 plus the square root of 2. Same thing on the top. All right, so you might want parentheses around this so that you can remember what you're doing. Okay, so square root of 5 times square root of 5 makes the square root of 25. Square root of 5 times square root of 2 makes a square root of 10. Then square root of 2, this is a negative, square root of 2 times the square root of 5 makes a negative square root of 10. Those, of course, are going to cancel. Then the negative square root of 2 times the positive square root of 2 makes a negative square root of 4. We're going to simplify. Square root of 25 is 5. These two middle terms cancel each other. The square root of 4 is 2. We end up with 5 minus 2, which is 3. Then we're going to do the top. All right, so this is distribute again. 4 times the square root of 5 is 4 square root of 5. And then 4 times the square root of 2 is 4 square root of 2. And you're done.